Well, for the next 15 to 20 minutes, I want to introduce you in a project that we are running in Esvenhal Ladenstein. It's a cooperation between many parties. It's called Better Water. It's Frisian for better water. In that project, we are looking for solutions to combine sustainable peatland management with also profitable land use. It's not running. How to switch over? Yes, this is working. Well, there was already a presentation about this Better Weather Consortium yesterday by a colleague called Ivan Metrop. He was talking about, let's say, the culturing of wet crops, especially Typha. And in this cooperation, well, all the, let's say, the quadruple helix works together. And I think that is crucial because we can work on, let's say, from, let's say, a water management point of view to improved peatland management. But if we cannot sell products from this peatland, I think it's very hard to make this transition, to make this sustainability transition. Douwe Hoogland this morning also expressed this. I think it's crucial to provide good opportunities also for farmers, especially. Because in the Dutch situation, the current land use is dairy farming, and farmers depend on this income from dairy. And if we want to tempt them to switch over to other business models, well, we have to find solution also for this commercial issues. So we work together with NGOs, governments, regional governments, academics and education, but especially with entrepreneurs. And I think that this story that I will tell you now really got a boost when a large regional building group, it's called Dijkstra Drijsma, get involved in Better Weather. They had, let's say, the ambition to invest in sustainable building concepts, and they joined us. And that's, well, we were very lucky with this. So profitable land use under wet conditions, how to go there. Yesterday, Ivan Metrop, I think he explained, I was not there, but I think he explained, well, these culture beds that we have in the northeastern part of Friesland. And we are culturing Typha there on the different conditions. But due to, let's say, physical properties of Typha, it has very good properties for insulation. And this building company called Dijkstra Drijsma, they joined us to see how, let's say, the culturing of Typha can be combined with a profitable business case, or a business case that will run. Well, you can make all kinds of products from Typha. We also work on biolaminate production. Well, it's very beautiful, of course. You can make furniture of this, but it's not a bulk market. It's for decoration, but you cannot, let's say, save the Frisian peatlands with these volumes. So for the bulk, we are focusing on insulation material, not on plates, but on insulation material for blow-in. So you see very small fibers of Typha between, let's say, 1 and 3 centimeters, and then it's applicable as insulation material in principle. But to have, let's say, a good product, we have 3 requirements what this product should meet. So if you blow this into these walls, well, it should not compress. So we do not want full in. It should be biologically stable, and it should have a competitive price. So, and if we can meet these three requirements, well, then there are opportunities to run this business. And this is how this value chain looks like. If you start at the left bottom, then it starts, of course, with culturing Typha. We have to mow it. We have to shredder it to a specific length of well, between 1 and 3 centimeters. We have to dry it. We have to sieve it, and ultimately we also have to conserve it. And that is nowadays it's done by aluminium sulfate, so it's a chemical conserving step. And then you have insulation material that is ready for insulation, and however it has to compete with competing products. And we compare this with cellulose, which is also let's say a circular building material for insulation, and that has a market price between 60 and 80 euro cents per kilogram. So if we want to make this business run, well, this is our, let's say, our reference price ultimately. Well, we are now, I think, well, Better Wet is running maybe for 6 years now. I'm personally involved for 4 years, and since 3 years from now, we are, well, let's say, culturing this Typha also on, and we mow it also from, let's say, bigger parcels than these culturing beds. So we are mowing and shredding and drying it now for 3 years. So we have 3 seasons now. We are mowing this, well, let's say by the end of October, and then it's dried, sieved, shredded, sieved, etc. Originally, we were drying this in a facility which dries grass for farmers, commercial facility, but it is, let's say, it is powered by fossil fuels. And it means a relatively high cost, but even more important also CO2 emissions. And that is especially what we want to avoid by this business case. And then originally it was pressed into bales, and well, let's say the disadvantage or the drawback of these kind of processing is that of this pressing is that you have a relatively high fraction of so-called fines, so very fine fibers which are not suitable for insulation. And then the recovery is very low. So if you then produce, let's say, maybe 7 tons per hectare, you only have maybe 1 or 2 or 3 tons of suitable material for insulation. So we had to optimize this processing. And we searched for alternative drying and shredding techniques, drying to meet this requirement of low CO2 emissions, but also low prices, and alternative shredding techniques to avoid these large volumes of fines, so to increase this recovery percentage. And on the right-hand side, you see just very simple boxes, which are normally used for, well, drying potatoes, etc. And well, we proved that also drying by just air, outside air, and this was done actually in winter, in February. Then you have also, well, let's say, dry cattail fibers within 5 weeks. And I assume that when you do it in summer or in spring, this period will even be shorter. So you can come to, let's say, 95% of dry matter, and that is also, well, what comes out of this commercial drying facility using fossil fuels. So this may be well, a cheaper and more sustainable alternative for drying. And then we have to sieve it. Well, you can see that this is just a very simple, relatively simple installation. And so the whole production process is quite simple. It's not high tech. But then the costs and benefits. Well, what are the determining factors? In this table, I just listed factors that are important. Well, for instance, the production rate of Typha, the yield. Is it 5 tons per hectare? Is it 10, even 15? This morning, I saw even higher yields. What is the recovery? So this fraction of between 1 and 3 centimeters of these fibers, what is the recovery of this fraction that is suitable for insulation? The price of the insulation material, what are consumers willing to pay? Are consumers willing to pay a bit more than this cellulose, for instance? What are planting costs? I think that this is an issue that is really, well, it's not totally clear. Maintenance during growth, the mowing cost for shredding, drying, and sieving. I think we have, well, really focused on these parts, land costs, and then also on the income. What is the amount of carbon credits that can be claimed? You can claim carbon credits due to rewetting, so that the peatland does not emit that amount of CO2 anymore. But also because you are growing Typha, and when you use it for insulation, you take it out of this carbon cycle, the shortened carbon cycle, and then you can also claim carbon credits for, let's say, the amount of CO2 that is gone into the plant by assimilation. And finally, subsidies. We have just subsidies for agriculture. Typha is now, you can get subsidy for agricultural subsidies for Typha culturing, at least in the Netherlands. Well, Albert is shaking his head, but okay. I think it's on the list of RVO, the Dutch agency. And then you can make these kind of graphs in which you compare costs on the left-hand side in orange, and also the benefits, so the income. And these are just the factors that I just showed, and I make premises for this. So in this case, I assume that the production is in the field 7.5 tons dry matter per hectare per year, that we have a recovery of 67%, that we sell the ultimate insulation material for 80 cents per kilo. Then we have investment costs at the beginning, so for planting, etc. We assume it for, in this case, just as an assumption, for 10,000 euros per hectare, with a depreciation period of 20 years, now, etc. And then in this case, you can make, well, let's say, a profit, a net gain of 2,300 euros per hectare. That's for, and then you have to divide this income between farmer, so the primary producer, and let's say the producer or the entrepreneur that makes also insulation material of all these Typha. When you make other promises, you have other outcomes. In this case, I just show a relatively low production of 6 tons dry matter per hectare per year. Also a low sales price of 70 cents, and then you see that this net gain reduces to, in this case, 1,600 hectares per year. When you have, let's say, an optimistic approach, and you produce 9 tons dry matter per hectare per year, you sell it for 80 cents, then I think that then this business case will run also in the Netherlands. When you compare it, let's say, what is the market value of grassland production? Well, estimates are between 2,000 and 2,500 euros per hectare. And I think that in this case, this will be profitable, and this business case will run, or this value chain will run in practice under these assumptions. Then about market volumes, to insulate one house, let's say in this way that we are applying, you need approximately 500 kilograms of ready insulation material per house. And then if you assume a net insulation material production of 5 tons per hectare, then you can insulate approximately 10 houses per year with the production of 1 hectare. So if you want to produce, as a building company, 1,000 houses per year with Typha as insulation, you need a production surface of approximately 100 hectares. I think that let's say the prospects for this are, I think in the Netherlands, but I assume also in Europe, are quite good. The Netherlands wants to build lots of houses for the coming 10 years. So let's say the government and building companies, they agreed to build 1 million houses for the next 10 years. And aside of that, also existing houses they have to be insulated. So I think that market prospects are quite good for, let's say, producing sustainable insulation material. So in principle, so what are let's say, the values for society of what I've showed you? I think there are income opportunities for specific locations, at least here in Friesland. So Friesland wants to increase or elevate water levels. So parts of lower parcels will become too wet for conventional dairy farming. And Typha cultivation may be an attractive alternative for these situations. Of course, you can combine this with regulated ecosystem services like water retention or water purification capacities, but also this depends on the design and the location. So it's situational. The same counts for restoring biodiversity. Also, this is situational. If you aim for multi-hectares of Typha plots, well, then this might be a tension for restoring biodiversity. It depends. Well, so you can go for, let's say, the highest yield, and to make this business case as more profitable, but it may also mean that, let's say, the values for ecosystem services, well, there can be trade-offs. So how to continue? That's I think that how to combine these values. I think that is a challenge. So my conclusion, I will end this talk, is that this value chain is quite simple. It is local and it needs low investments. I think that's important. There is an increasing demand for bio-based and sustainable insulation products. And there may be a tension between market demands, it means efficient production, and society demands, which means biodiversity and landscape. But this is between question marks. Maybe we can combine this. I think that the main conclusion is that carbon credit subsidies and/or increased insulation product prices are necessary to make this value chain profitable for both farmers and product producers. So also in case you raise this price for, let's say, the market price of this product to maybe €1 per kilogram, I think that this business case will run indeed. But for this moment, at this time, I think that the governments have, well, a crucial role. It means that they have to make policies that support sustainable land use under wet conditions. For instance, by facilitating carbon credit certification for individual farmers. So if you want to claim carbon credits, you have to be certified, and this certification process is relatively expensive when you do it as an individual farmer, and the regional government can support this. Then insights and need for developments. We need better insights in costs and benefits. Well, I just meant planting costs and Typha. I think that these are the production yields. These are the most important. The variation in practice. So we have experience at several locations. But I think that this is, well, we have to extend these amount of locations, and we have to get insight in this variation under practical conditions, so at different locations. I think also important, we need better insights in the effect of nutrients availability on Typha yields. So these tons per hectare, these production yields are quite important for this value chain or for the business case. And as a further development, it's not new, it was mentioned before these days, valuing ecosystem services for sustainability transition. So how to translate these societal values into money for farmers and landowners. So it makes it more easy and less risky to make this transition for them. And with this, I want to thank you, and I want to thank you especially all these parties and persons listed here. Thank you very much.